Alright, as usual, we saved the most difficult question for last. It says, example 4.2a.4, it says a ball is thrown vertically off a Washington Monument, which is 169 meters tall, at 15 meters per second. How long will it take to hit the ground? So we are looking for time. We know it's going to be under the influence of acceleration due to gravity, so we know if that applies. We also know that the initial velocity is a positive 15 meters per second. And we know that the displacement of the ball, it's being thrown off of the Washington Monument, is going to be a negative 169 meters. We know it's going to be under the influence of gravity. And so we can apply if that. We say the initial velocity, the displacement, the acceleration, and the time. So we pick the equation that does not have final velocity in it. And that is delta D equals VIT plus 1/2 AT squared. Now before, we got used to the fact where this term would cancel out because it was dropped. In this particular case, it's not dropped, so that term will not go away. So what this is actually going to look like is you have the Washington Monument, you're going to throw a ball up in the air, and you want to know how long it takes until it hits the ground. So, we plug in our numbers. We say, okay, delta D is negative 169 equals 15t. I'm going to go ahead and just simplify this and say negative 4.9 t squared. And where I got this from was just 1/2 times negative 9.8. I just wanted to save a little bit of room because I know where this is going. So what you should recognize is this right here is a quadratic equation. You want to put it into a little bit easier form to work with, so you should say we're going to take these things and move it over to the other side. And the reason why we want to do that is we don't want to have a negative a value. So we're going to have 4.9 t squared minus 15t, because remember the signs on these switched as I moved them over to the other side. Minus 169 equals 0. Now you could, of course, you could factor this, but it's going to be almost impossible for you to find a common factor. So really what we're going to do is we're going to use the quadratic formula. The quadratic formula, remember, is x, in our case t, equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. With this term being a, this term being b, and this term being c. So what this is going to look like is, the first term is negative b. Well, negative of negative 15 would be positive 15. So positive 15 plus or minus the square root of 15 squared, excuse me, negative 15 squared, minus 4.9, negative 169, and all of that divided by positive 9.8, which is 2a. So now we plug in our numbers into the calculator, and we're going to say, okay, 15 squared minus 4 times 4.9 times negative 169 is going to be 3,537.4. But remember, that is all under the square root. So I'm going to go ahead and take the square root of that. And I'm going to say, okay, we have 15 plus or minus 59.5 divided by 9.8. Now, realize at this point there's only one solution that makes sense. If I do 15 minus 59.5, that's going to give me a negative value. And what that means is that this ball is going to take a negative amount of time to reach the ground. What this is this is the imaginary continuation of this function, where if you took it back to the origin, this is what it would be. But it doesn't make sense in this particular case because you cannot have the ball hit the ground before you throw it. So that solution, although it makes sense mathematically, does not make sense in the real world. So we have to take the plus answer. So you have 15 plus 59.5 divided by 9.8, and that gives you a time of 7.6 seconds.